Yeah. How are you guys? Going good till now? Better? Yeah. So, are we ready? Good. So basically, as you have seen in the poster, we are here for the AI in action. Yeah, AI stuff. So much more interesting nowadays. It's basically a journey about how did we shift from automatic manual topic description to the automatic topic discovery. It's more of a tagging to discovery journey. Okay, before starting it, next, I'll just like to introduce myself. My name is Pratik Dhulubulu. Yeah, it's pretty weird name, I know. It's for Marathi people, I will tell you, this is Dhulubulu. So it's in Marathi, and other Hindi people, you can call me Dhulubulu, no worries. Yeah, I have these, I do these things, and I'm more interested into films, theater, music, and all other stuff. Okay, now we will start with the main topic, and the main topic started with a question: how do we analyze millions of responses effectively? Anyone wants to give input, like how can we analyze the top response? Basically, we are a survey industry. We are a survey tool, right? We get millions and billions of responses for multiple surveys, and we cannot judge each and every response going by each and every response by itself, right? So there has to be any plan to get into those top responses and then find out the analysis out of it. So this was the main aim of it. And then we started thinking and came up with the idea, a topic modeling. We can although we cannot analyze millions of responses, but we can at least analyze 50 or 100 topics, categories. That is much easier, right? So we thought the responses are like a river. You can see the river in the right, and then we created some containers on the left hand side. So those are the folders which are topics. So basically, what we did is we created a central system which will pick up a bowl of a water, which is a response, and put it in the exact or the closer topic that was more describing the response, right? So it made us easy to analyze lesser number of topics, but giving the whole idea of the responses, all the responses. Yeah. So this was the idea. Then we started working on it, and then we kind of got up with a new tool, which is the Discover. Discover used to do all the other things I mentioned in the previous slide, and also get the sentiments out of the responses, and that's how it helped us to analyze in which in which category or criteria we had to work on, or the client has to work on, so the improve the quality. It can be food quality. So in the previous slide, you must have seen the restaurant business analysis it was, and then suppose the restaurant is lacking in food quality, but the ambience is too good. Yeah, it's Instagrammable cafe, obviously. But if the cafe gets better in the food quality as well, the overall capacity will, or overall reach will grow. That's why this helped all the other clients. We will look into how did the Discover work. It was pretty straightforward. We had to predefine some topics according to the industry. Suppose there is a food industry, we can consider the food quality, the ambience, the other amenities. Suppose it's a lodge, then it's a room service and all other things. And it was pretty easy. We are just tagging the topics to the responses, and it was easy for us to analyze the topics. But, so what happened is the NLP based system used to tag the find the patterns out of the text and then tag the to the particular topic, and also NLP system used to extract the meanings of it. We can go ahead. Yeah, but the issues started flowing on. What happened is while going or tagging the topics or the responses to the topics, we were always needed to create the topics in the first place. For the each industry, we had to create some predefined topics, and it was like PDMs be like, "Yo, man, give me the topics fast, fast, fast. We cannot make the client wait long for long, right?" So it used to take couple of days, sometimes weeks, because who are creating these topics? Here I have written, so product experts, industry experts. We have to have the industry experts who have the knowledge, the thorough knowledge about the industry, and then we can analyze the industry thoroughly. Then efforts was invested, and by the in the sideline, time was getting so much wasted, not wasted, but yeah, it was utilized for lesser, which can be optimized. Then another issue occurred. Next one, emerging topics. So anyone can come up with what this made uh, think us. What made us think about this? Any idea that anyone can tell me any such scenario that was unpredictable at on the larger scale? Quite recent, not so recent. 5 years been there. COVID scenario, right? Would have predicted the COVID topics in all these? So was the if there was a hospital industry, and who would have predicted the COVID? If someone had China, we never know. But what happened is we couldn't get the emerging topics. Those are not defined previously. We were failing to get the analysis out of that data, and the painful reality hit us. What was it? We were always looking backwards, not forward, and that's how we started thinking again. Next, but this time the question was slightly different. How do we analyze the responses smartly? And here comes. Whenever we listen the word, see the word, read the word smart, what comes in mind? What? Nothing? Anyone? Anyone? Of the box idea? Yeah. Nice. And currently the whole out of the box idea is dependent on the AI. Right. So we started thinking about it. So the person is also happy. No books are there. We are now smarter. So we started thinking about it and then went ahead with the idea that what if we utilize AI in it and let the AI do next type which let the AI fetch the topics out of the data instead of tagging them. And the whole philosophy was so the river has become the waterfall now. The responses are pretty fast, but the bubbles are emerging automatically, easily, pretty easy, right? The whole approach towards this was let humans focus on interpretation and strategy. Let AI do all the other shit stuff, right? Cool. Let's go ahead. And that's how we come up with the answer. The whole question ended here. Till now, we are here. So we never know any question might occur in the upcoming days. But yeah, the AI topics. We found out that we can extract the topics out of the data utilizing AI at its best. So this journey started like that. Next slide. Yeah. Yeah, yeah, yeah. I have a slide ahead, so that will help us understand how things work. Uh, The fundamental shift that we wanted in our product, first discovered and then AI topics. Discover's approach was best where we had the predefined topics, right? So here are the topics and here are the texts. Just tag them. And AI topics was approach was here's the text, discover the topic. Whatever I'm saying since the start, it's discover the topics within it. The technical term is moving from supervised classification to unsupervised classification. We moved from supervised to unsupervised. Before we had to do topic curation, and that step got eliminated thoroughly, and that helped us improve the time output. Uh, this was the whole idea, and this step we wanted out of it. Next, so basically we started designing the AI topics, and these are the basic steps which will be coming, which are there in the AI topics. So first of all, we had to find out the essence of the responses until and unless the juice of the sentence, what the customer wants to say, we cannot find the exact emotion and exact feeling about the particular service category topic about it. So yeah, as Angad mentioned, I will just put in one example here. So if suppose a client wants to know or customer is speaking about, suppose it's a restaurant, the burger was pretty good, but the light was pretty dim inside the cafe and service was poor. It had kind of three topics inside it. Can you guess? Can you guess? One was ambience, light, taste of the food, and the third one, service. So basically, we have to get the whole essence out of it using these three topics. And how can we get it? So we had to get the essence of the text out of it. Those we will be calling text features from onwards. Okay. Those are easy to understand. Food, burger, service, speed, service speed, and third one is the ambience. It was easy. But suppose the other person is speaking about the khichdi that cafe made. Now the essence is khichdi, the taste of khichdi. It's pretty good or pretty bad, whatever it can be. Now the other person is talking about khichdi. Now we cannot have burger and khichdi as different topics. Those are lying into the same category, which can be food. To get that kind of analysis, as we are not defining the topics previously, we had to analyze those things are lying in the same cluster. And that's why we came up with the semantic embeddings. I will give you better understanding of semantic embeddings in the upcoming slides, but just the idea of it. And then clustering those embeddings utilizing BERTopic Clustering Engine and then representation labeling. These are the four basic steps we worked on and got the output what we wanted. Let's go ahead. Okay, now the text features. Here is the another example. Here there is a large response that a customer wrote about some sport, some television industry that they are getting paid. So other than the Olympics, I have no interest in watching major league sport of any sort and hate paying for something I never use because the television company must have been selling multiple packages and that it must have had multiple channels with it. And the second one, I guess the sentence ended there and do not take me to another program as one is ending unless it is in my list or at least ask me if I would like to see the program. I really hate that feature. So we are getting the when we are reading the response, we are getting the information that the program is switching automatically when one is ended and the another one starts, but clearly the user hates it, right? But how do we get to know the things out of it, essence out of it? We generated two things here. Sports content billing. First of all, don't bill me for everything. Bill me for whatever I want to watch. And the other one is autoplay, auto program switching. These are the exact things those were generated out of this response. And I have mentioned sentiments here. Along with this, we fetch multiple other things, but I won't go into that much deep details. And these are the sentiments only. I will just go with these things for now. These are the text features, and those will be generated into embeddings, semantic embeddings. Next one, semantic embeddings. Embeddings. What are the embeddings? Anyone has worked on embeddings till now? Whoever is here. Okay, cool. Embeddings is a basically, yeah. Anyone? Anyone said anything? Cool. Okay, so embeddings are the numerical form of your context or the text. So whatever text we uh, themes, right? Billing. Billing was the theme. Whatever themes we got, we converted them into machine understandable language, which is numbers. Those are basically array of float values. And yeah, just try to understand if you get it easily, pretty easy. Embedding of king, embedding of man, and embedding of woman. There are three embeddings in the second one. This is the classic example to teach embeddings. So I've just put it there if anyone don't know at all. So if I go with the word king textually, I'm not symbols, king characters, king, women, man are totally different, right? And queen is totally different. But when I talk in the terms of embeddings, if I take the king embeddings of king minus the embeddings of man and add the embeddings of woman, what does it give? It gives the queen because the king has the uh, position, authority, privilege, and another thing is gender. We are taking out one gender, putting in the second one, authority remains, and the queen becomes, right? So this is the basic idea. Why does it help? Fast service and speedy service are both the same, right? These two will lie on the same, not exact point, but same in the same cluster. Okay, so this was the idea, and uh, that's why fast service, quick response. These two will lie in the same cluster. Did you get it? Any question till here? Cool. Can go ahead. Yeah. Okay. Cool. Let's go. Perfect. And then we had to utilize the bird topic clustering. Uh, these are pretty. Bird topic clustering does the clustering part of it. We will go through it. Uh, First, there will be UMAP. Second, there will be HDBSCAN. And third, there will be c-TF-IDF. TF-IDF, anyone must have heard about dimensionality reduction. Okay. So you can, everyone can see the image in the lower part of the slide. Can anyone? Okay. Everyone can see it, right? I'll just explain that. And I will try to tell you how does things work behind the scenes. Okay. So first of all, we have converted the each theme into the embedding. That is the first part. Then there is the simplify. Yeah, there is simplify. Simplify is basically UMAP. What does UMAP do? UMAP does dimensionality reduction. Dimensionality reduction. What is dimensionality reduction? When we generate the embeddings are we are using 768 dimensions. How many dimensions can we see? we see in three three dimensions, right? Basically, that's how we can watch the 3D movie because we cannot have the four dimension. 4D is there, but the seats are pretty bad, right? So 3D, three dimensions can we can watch, see through our eyes. We are creating 768 dimensions for a single theme. Like it's an array of 768 float values, and that represents that particular theme or word. Now it's pretty difficult for our systems to handle. Why? HDBSCAN cluster does the clustering, and then it requires all the embeddings of the data at one single time in its memory. And it's not quite possible, and it's pretty difficult to handle 768 dimensional uh, embeddings of all the things can be million responses, right? And each response had multiple themes. So it's pretty difficult to billions of handle billions of embeddings. So UMAP does reduction. It reduces it 5 to 6 dimensions. Those are still understandable, differentiable, and we can cluster out of it. So my question here is, why didn't we start with 5 dimensional embeddings? It was pretty easy, right? We would have never needed the UMAP. Why? Anyone? Hmm. Yeah. Yeah. Right. Quite there, but good attempt. Anyone else? Okay. If I tell you, tell me about yourself in one word, and if I tell you, tell me about yourself in 4 lines, you can use 40 words around, which is easier using 40 words, right? And it will be more descriptive, right? It will have much more data that you want to express, you want to convey, right? That was the way, that was the way the embeddings are generated initially. Because it had a hell lot of data, we have to convey it. After generating the 768 embeddings, it the cons XY graph, imagine XY graph. Now instead of X and Y two axes, imagine 768 axes. Okay. Now the each point is getting plotted on the graph, and then we are just changing it into the 5 axial graph. Okay. What did it do? It gave us better understanding of data. It first generated the thorough detailed embedding, and then the detailed embedding got converted into 5 dimensional. It is better than generating directly 5 dimensional or 6 dimensional graph, sorry, embedding. Okay, it had more data. That's why first 768 and then converting it into 5 to 6 dimensional, because we want to find patterns out of it. The HDB scan does the clustering on the embeddings, and that helps to analyze the data. The clustering, you must have heard about the k-means and all other techniques, right? Yeah, BERT does the similarly same kind of HDB scan does the same kind of thing, but in a different way. We won't go exactly how does it do because yeah, time constraints, and but it does the clustering. If you can see the graph, it analyzes the embeddings and clusters them into multiple clusters. grouping them into multiple clusters, and then c-TF-IDF does the topic representation. We will okay. When when a cluster is there, and how would you analyze? So basically, what did the HDBSCAN do? It did the clustering and gave a group of words, random group of words. Those were closer, and it was easier to group them in a single cluster. How would you name them? Why would you name them? First of all, why do we need to name them? Yeah, context, that is more important. The context, what the group is representing, we have to get the understanding of that group easily out of one or couple of words, right? Otherwise, it's we are making nothing sense then. Because if we want to go each and every word in the cluster and then analyze it, nothing makes sense. The journey started for the topic, right? We wanted a topic. We wanted a single word that was representing a multiple thousand millions of records. So that's why we wanted topic representation, and we are using the c-TF-IDF. TF-IDF, anyone must have heard about it. Uh, Anyone? No? The TF-IDF does basically inverse uh, inverse document frequency. Anyone? So inverse indexing must have heard about it. Anyone heard about it? How about the inverse indexing? Anyone heard about indexing? Indexing. So basically, kind of same thing, but thoda sa ulta. Okay. Inverse document frequency does what? It will check which word has occurred most of the times. Okay. In simple words, which word has occurred most of the times in the whole cluster, and will pick up 10 most occurred words. That's all. Basic idea. Cool. Cool. Yeah, better. So that will help us to analyze the 10 best 10 words those are representing. Now, uh, till what journey we have come, if you are getting it. We had multiple millions of records, then we generated multiple millions of themes, but those themes got clustered into 70, 80, 90 topics, but each topic had thousands of words, but out of thousands of words, we picked up 10 most frequent words, and those are representing that particular topic. Easy till now? Perfect. Now we want to name them. So here the CTF IDF gives us the idea. So basically it provides us the 10 words. Can we go next? These are the better detailed information. We won't go too much into it because it's pretty difficult. If anyone wants to know, I will share the slides as well. No worries. Next. This is the TF-IDF formula and all. You can find it afterwards. Uh, okay. We will come to this slide later. First, I've started the representation labeling, so I will complete it. So, what did the TF-IDF gave us? Good, just bottom right corner, if you can see, before but raw topic labels. C-TF-IDF gave us good, great, excellent, amazing, fantastic. These were the words which were the most occurred in the cluster. Yeah, we are getting the whole idea right out of it. Are you getting? But if we utilize the LLM, and get more meaningful, sensible topic out of it, right? Overall satisfaction and positive experience. So this is the OpenAI. We are utilizing OpenAI, but we can utilize any other LLM as well. We can host our own LLM and then utilize it for topic labeling. We are labeling the topic. That's why representation labeling, what is whatever the topic is representing, we are labeling it using the LLM. We have to provide the LLM the keywords and documents. This also gets done by the BERT, but this is optional. That's why I'm explaining this separately. Keywords and documents. Keywords are the main keywords which were occurred multiple times, and the whole documents, what were the themes. These two things LLM text and returns the representation labeling. It is pretty easy, right? Look at that. Quick, fast, rapid, speedy prompt, service speed, and efficiency. More descriptive, more detailed, more sensible. Wait, long, slow, delay, forever. Wait times and service delays. We will require a good prompt for this to generate. Otherwise, the topics will also get messed up. Cool. We'll go on the previous one. But for doing all these things, first of all, how much, what dimensions embeddings you are using? What UMAP? I was not sure, right? 5 dimensions, 6 dimensions, 5, 6, 5, 6. What dimensions you are bringing down them to? What configurations you are using for HDBSCAN? So basically, understanding 100 responses and understanding 100 million responses is a totally different game, right? We cannot use the same tactics for both these scenarios. So hence, we came up with the dynamic configuration rule where we were pretty more aggressive when there was little less data, because each topic must be having like 5, 10, 20, max 50 responses till 1000. If there are 1000 responses, then each topic must be having 50, 20, 20 to 50 responses, right? So we had to find out more deeper meaning out of it and cluster them accordingly. But when the larger data sets occurred, 10,000 plus, a lakh plus, a million plus records were there. Conservative parameters, as suppose khichdi and burger made each separate clusters. What would you do? Burger, pizza, khichdi, bread, whatever it is, coffee. Each dish will start having its own cluster, and then again, you are getting 10 thousands of topics. You need to analyze all of them, and which never made sense. That's why we started it. We want them to cluster in the food, right? So that's why large data sets, conservative parameters, larger topics, and better understanding. Next. Yeah, that was it from my end. Thank you. Yeah, yeah, sorry. Go ahead.
So I had a question. It's a pretty basic question. How do we handle ambiguous data? I mean, when there's no, response is not right or there are signals or something like that.
Yeah, that whatever we talked about right now, it was analysis part. The data manipulation or engineering part is mostly done before it, prior it. If there is, but usually in survey industries, mostly the responses are collected all together, and the HDB scan while clustering it captures the noise as well. Suppose there are 1, 2 responses only regarding a particular topic, it will avoid them. It, so basically, each cluster has to have huge amount of a certain the configuration we did for the HDB scan has to have a certain amount of, we put a threshold. Each topic has to have a certain amount of weight. Until that, we cannot qualify that cluster as a cluster. Okay. If some responses or themes are not considered in the topic, then it is thrown out of the clusters, and then it basically tags -1. Basically, it means that it is outlier topic. It doesn't belong to any topic, and that's how we get the outlier topic, and we can analyze them separately. Those are less amount of data, sometimes 1%, 2%. Yeah.
Also, the LLM used for the question pro, is it trained in-house or is it
No, currently we are using OpenAI for now. Yeah. Anything? Cool. Good to go. Yeah. Have a great weekend. Bye bye.